Welcome students in the organic chemistry lecture series. In this video we are going to see in detail about few examples of RAS nomenclature system of optical isomers. In previous video we have seen in detail about the CIP rules for naming the optical isomers by RAS nomenclature. In this video we are going to study few examples so that the rules will become clear to you and you will understand the system of nomenclature. So I will take a very simple example. Consider this example. Here is suppose OH group, here is suppose Br, here is a CS3 group, and here is suppose hydrogen. Now as per our rules we have to arrange these four groups with their atomic number, increase in atomic numbers. So the first priority will goes to this bromine because bromine have highest atomic number in these four atoms. So first priority is to bromine, then second priority is to oxygen, third priority is to this carbon, and fourth priority is to this hydrogen. So the wheel will rotate in this way from 1 to 2, 2 to 3, and from 3 to 4. So in this way there is a direction of rotation, so this direction is clockwise. So this isomer will be called as a R isomer. Okay, so in this way we can give the nomenclature to these compounds. Now here you see that lowest priority group, that is hydrogen, is on vertical line, so configuration will remain as it is, it will not change. Okay, we'll take another example. Suppose here is a CH2, CS3, here is a CS3, here is a OH, and here is a hydrogen. Okay, now if you compare these four groups, then oxygen will have highest priority, so give number 1 to oxygen. Now second number will goes to this carbon or this carbon, that we have to decide from our rules of this nomenclature. See, here is a carbon, here is also carbon, both have same atomic number, so we have to consider next atom to which this carbon is attached. Okay, so this carbon is attached to three more hydrogen atoms, so it will be 1 plus 1 plus 1, so it is 3. Here this carbon is attached to 2 hydrogen, that means 1 plus 1, and 1 carbon, so it becomes 6 plus 1 plus 1, that is 8. That means this group will have the highest priority, so we will get 2 number to this group, 3 number to this group, and this hydrogen will have the lowest priority. Okay, so wheel will rotate in this direction from 1 to 2, 2 to 3, and from 3 to 4. Okay, so this is anti-clockwise direction, so it is yes, and the lowest priority group hydrogen is on vertical line, so it will not change, so S configuration, this is the correct answer of this configuration. Okay, we will see more example. Now consider this example. Suppose here is a chlorine, here is a hydrogen, here is a CHO group, and here is suppose CH2 OH. Now this example is little bit difficult than these two. Okay, so it is, first of all we have to give the highest priority number. Now if you see this hydrogen, carbon, carbon, and chlorine, we know that chlorine has highest atomic number, so chlorine will get first number. Now second number, whether this carbon or this carbon, we have to decide. Okay, now both these are carbons, we have to consider next atom. Now this CHO group we can draw like this, H, and double bond O means we can write like this. Okay, and this carbon has 2 hydrogens and 1 oxygen. Okay, so count the numbers, so 1 plus 8 plus 8, so it is 17, and here 1 plus 1 plus 8, so it is 10. So this CHO group will have second priority. Okay, so second priority, this carbon will have third priority, and this hydrogen will have fourth priority. So we will rotate like this from 1 to 2, 2 to 3, from 3 to 4. Okay, so this is which direction? This is anti-clockwise direction. Okay, anti-clockwise, so yes configuration, but remember the lowest priority group hydrogen is on horizontal line, so the configuration yes changes to R. So this rule is very important. You remember this. If you read it from any book, you will not understand this rule of conversion. But I am explaining it in very simple way. Just remember, if the lowest priority group is not on vertical line, then configuration changes. Right? So these are the three examples. We'll see few more examples. Say for example, suppose here is a CS3, here is a hydrogen, here is a OH, and here is a suppose Cl. It is very simple example. We know that this chlorine will get first priority. Okay, then hydrogen will get second priority. Sorry, oxygen will get second priority. Okay, so this oxygen will get second priority, this carbon will get third priority, and this hydrogen will get fourth priority. So will be rotated like this: 1 to 2, 2 to 3, 3 to 4. So this is clockwise, so it is R, but lowest priority group is on horizontal line, so it changes to yes. So this is the correct RS nomenclature of this compound. We'll see one more example. Suppose here is a NH2, here is a SH, here is a suppose CS3, and here is a OH. Okay, now we know that sulfur is having highest priority because its atomic number is more than oxygen. So 1, it will carry 2, it will carry 3, and it will carry 4. Okay, so we will rotate like this: 1, 2, 3, and 4. So it is anti-clockwise. So we can write the configuration as yes, and the lowest priority group is on vertical line, so it will not change. So these are the few examples of RS nomenclature. Okay, now we'll see some examples in which there are two stereogenic centers like this. Suppose here is a CS3 group, here is also CS3, here is suppose hydrogen and OH, here is suppose Br, and suppose here is a suppose here is also say Cl. Okay, now consider this compound. Now there are two stereogenic centers, this one and this one. So one by one we will see. So consider this stereogenic center first. Now on this stereogenic center, this whole group will be considered as a single group. Now you see that this is carbon, this is oxygen, this is carbon, this is hydrogen. So this oxygen will get first priority. This carbon will get second priority because this carbon is attached to chlorine, bromine, and carbon again. This carbon will get third number, and this will get fourth number. So we will rotate like this: from 1 to 2, 2 to 3, and from 3 to 4. So it is anti-clockwise, so it is yes, but the lowest priority group is on horizontal line, so it will change to R. So the configuration of this carbon is R. Now consider this carbon. If we consider this carbon, then this bromine will get first priority, chlorine will get second priority, this whole group will be considered as a third priority, and this carbon will be considered as a fourth priority. Okay, so the wheel will rotate like this: from 1 to 2, 2 to 3, and from 3 to 4. So it is clockwise, so it will be R, and the lowest priority group is also on vertical line, so it is R. So this configuration of this carbon is also R, and configuration of this carbon is also R. Okay, so in this way we can give the RS nomenclature to the isomer in which there are two stereogenic centers. Okay, I will take another example. Suppose here is a CHO group, here is a CH2OH group. Okay, now consider another example. Now first of all, see this stereogenic center. This oxygen will have first priority, this CHO. Now see here, this is also carbon and this is also carbon, but this carbon is attached to one hydrogen and one oxygen, but this carbon is attached to one hydrogen and double bond O means two oxygen. So this will have the second priority, remember. Okay, this will have third priority and this will have fourth priority. So wheel will be rotated like this: from 1 to 2, 2 to 3, and from 3 to 4. So it is clockwise, right? R, but lowest priority group is on horizontal line, so R changes to yes. Okay, now consider this stereogenic center. This oxygen will have first priority. Now see, this is also carbon, this is also carbon. This carbon is attached to two hydrogen and one oxygen. This carbon is attached to one oxygen and one carbon. That's why this will have the second priority, this will have third priority, this will have fourth priority. So wheel will be rotated like this from 1 to 2, 2 to 3, and from 3 to 4. So again it is clockwise, so it is R, but lowest priority group hydrogen is on horizontal line, so this R changes to yes. So both the configuration at stereogenic center is yes. So in this way, this RES nomenclature system is very helpful for determining the configuration of one stereogenic center or two stereogenic center, etc. So there are a lot of examples you can refer from the books to make practice of this RES nomenclature. But remember that RES nomenclature of optical isomer is a widely used method of naming the optical isomers of its configuration. So it is very important. You can find the question on this RES nomenclature system on any examinations related to stereochemistry. You will find the question on this RES nomenclature. So this RES nomenclature system is very important. I will just summarize the rule. First of all, you have to arrange the four groups. Arrange the four groups as per the atomic number. Give the highest priority to that group which is having more atomic number. Then second, if the two atoms are same, then consider the next set of atom. Calculate the overall atomic mass of the next set and then determine its priority. If again there are isotopes, then you have to consider the atomic mass while if there are the isotopes. And again, if there are double bond or multiple bond like triple bond is there, then you have to consider that atoms in that way. If double bond is there, then you have to consider that atom twice. If triple bond is there, then you have to consider that atom thrice, like this. So in this way, and again another important rule is that always lowest priority group should be at vertical, and if it is not on vertical, then that configuration changes to next configuration. Okay, so this is called as conversion rule. So this is all about RS nomenclature system. It is very simple and very important in any kind of examination. So okay, so have a nice day, and we'll meet in next video with another concept in stereochemistry. Thank you.